So we've talked about solving a system of equations, and we said that when you solve a system, you're basically finding the point, which is an x comma y coordinate, of intersection where the two lines cross. However, there are special systems in which if you have a line, let's say it looks like this, once you graph it on the coordinate plane of x and y, and then you graph another line that is parallel to it, they never cross. And so as you can imagine, when you have a system, two lines that are parallel, it means there is no solution because there's no point of intersection. So that's one type of special system, when the lines never cross and you get no solution. And then the other type of special system is if you did have an equation of a line that once you graphed it on the xy coordinate system, for example, let's think of one. Let's say y equals 2x minus 1. I would graph by beginning at -1, and then the slope, as you recall, is 2 over 1, because b is -1, just as a refresher. You would go up 2 units. If this is -1, you would go up to 1, and then you would go over 1 unit. So up 2 over 1, and then up 2 over 1, and you would connect the dots as best as you could. And if I gave you another equation, such as 4x plus, actually, let's do minus 2y is equal to 2. If I put this in slope-intercept form, so I'm going to do this one quickly. You're going to minus 4x. You're going to get that. If I continue this, you get -2y is equal to -4x plus 2. Then you divide everything by -2. Y equals 2x minus 1. You notice that the equations are the same. So if I'm going to graph the red equation, 2x minus 1, y equals 2x minus 1, and I'm going to graph the equation that we wrote in black, y equals 2x minus 1, I'm going to get exactly the same equation, the same line, which means that it's going to be intersecting at every point. So every point is a solution. So as you can imagine, this is called infinite solutions. There's a couple of more vocabulary words that have to do with this, which we're going to go over now. But I just wanted to make sure that I give you a quick little overview on something that I know you probably can make sense of, the all real numbers or infinite solutions and no solutions. So parallel lines never cross, there's no solution. If you're graphing the same line, or if you have two lines that are exactly the same, they're obviously going to cross at every point. So now let's talk about some more of the vocabulary points. Vocabulary for this unit. When two lines intersect at a point, in other words, when you cross and you have one point, there is exactly one solution to the system, and a system with at least one solution is called a consistent system. So if you have at least, now this is the key word, at least one solution, we call it a consistent system. Similarly, if you have two lines that do not intersect, so this is our parallel lines, they don't cross, they're parallel, and there are no ordered pairs that satisfy both equations. In other words, there is no solution. That is called an inconsistent system. So if you have a solution, it's consistent. If there's no solution, it's inconsistent. That's one part of it. In addition to it, if you have only one solution, then it's an independent system. And if you have infinite solutions, it's called a dependent system. So if you have a solution, it's consistent. And if that solution that you have is only one solution, it's independent, so that's consistent, independent. And if they don't intersect, it's inconsistent. And if you do intersect and you have more than one solution because it's infinite, then it's dependent. So let's go over this visually because I know sometimes the words are difficult to understand. Let's say that we graph our line, red line and blue line. There's only one solution. That means that it's consistent because there's a solution, and it's independent because there's only one solution. Now, let's say you graph the two lines. You graph the red line, and then you graph the blue line on top of it because it's the same system. There is a solution, therefore it's consistent, but there's infinite solutions, so it's dependent. So if you cross at one point, let's put it this way. If you cross, you're consistent. Or if there's a solution, so if there's solution or solutions, it's consistent. If there's a solution but there's only one, then it's called independent. And if there is a solution but there's infinite, because it's the same line, then it's called dependent. So the word independent is telling you there's only one solution. And the word dependent tells you there's infinite. Now, if you have no solutions, it's just inconsistent. So the only thing that you really have to understand is that consistent means there's solution. So if you don't cross, you're immediately inconsistent. If you are consistent, in other words, if you have a solution, but it's only one solution, you are not just consistent, but independent. And if you have a solution, but it's infinite solutions, then you're not only consistent, but you're dependent. Because every value depends on each other, because it's exactly the same. Independent is like it stands alone. There's only one solution, so that's independent. So let's look at some examples. This is an example of a time when you would have no solutions. And again, we're dealing with two equations at once, two linear equations. Two linear equations are equations that become lines when you graph them. So if I graph two lines and they're parallel, it means they never cross. And if they never cross, it means there's no solution. So if I took this example, y equals x minus 1, and I took negative x plus y equals 2, these are two equations, therefore it's a system. The first way to actually figure out whether there's any solution is to look at the slopes, because if I know that the slopes are the same, then it means they never cross, which means that there's no solution, which means it's inconsistent. So let's look at the slope. Let's see. The slope of the first line, it's understood to be 1. The slope of the second line, I would have to convert it into y equals mx plus b. I would add x to both sides. I would get y equals x plus 2. Yet again, the slope of this one, the red one, is also 1. So the slope of this is 1, and the slope of this is 1. You can't assume right away that they don't cross, because you have to remember that if you are parallel, you don't cross, but if you happen to have the same slope and the same y-intercept, you are going to happen to be the same line, which would mean that you're infinite solutions. So you have to look at slope and y-intercept. The y-intercept of the blue one, which we will actually call this one, the y-intercept of the blue one is negative 1. The y-intercept of the purple one, which is this one, when I put it in mx plus b, the y-intercept is 2. So this equation is telling you you have two different y-intercepts, but the same slope. That means you're crossing at two different points, negative 1 for the blue one and 2 for the purple one, but you have the same slope, which means it's parallel. So this means there's no solution, and when there's no solution, you have to remember that that means that it is inconsistent. We can graph the system. This is a different way of looking at it. So way number one is to actually algebraically look at the two equations and look at their slopes and y-intercepts. If we have the same slope and we have different intercepts, it means you're parallel. So the second way of doing it is to actually graph the system. And when I graph the system, when I put them both in y equals mx plus b, it's basically what I did up here. So the purple line would be at 2 for your y-intercept, and you would go up 1 over 1. Connect the dots, there's your line. And the blue one would be at -1, up 1 over 1, like the other. So you notice that they never cross. The third way to do this is to solve it algebraically. That would be to look at this system and to maybe solve by substitution. You know y is equal to something, x minus 1. So to do this algebraically, you would write down the system of equations. So we have y equals x minus 1 and negative x plus y equals 2. You could either substitute or eliminate. I would probably substitute because you already know what y is equal to, so you could plug it in there. And you would get negative x plus y, which is x minus 1. That's what y is equal to, because it tells you right there. And that equals 2. And then I would get negative x plus x. They cancel out. Negative 1 is equal to 2. What? No solution. False statement. No solution. So that is the third way that you could solve. So remember, when you're looking to find whether you have any solutions or none, you look at the slope and the y-intercept. So let's look at this one. Compare the slopes and y-intercepts. Let's see. I am going to call this one up here the purple one, and we'll call this one the blue one. The slope of the purple one is 2. The y-intercept is 1. In order to put the blue one and find the slope-intercept, I would put it in slope-intercept, which means I would probably be easiest to add y to both sides. And then you would get 2x plus 1 is equal to y. And when you look at it as a y equals mx plus b, you could tell that the slope is also 2, and the y-intercept is also 1. That means it's exactly the same line. Therefore, it is what we call infinitely many solutions. Second method of doing the same question is to graph it. So we can graph the purple one, y equals 2x plus 1, beginning at 1, and going up 2 to the right 1. Connecting the dots. And then I can go to the blue one, and I could see that it's the same thing. I begin at 1, up 2 over 1. You're the same line. And if you're the same line, it means you cross an infinite number of points. Then we can solve the system algebraically. Well, the equations originally were y equals 2x plus 1 and 2x minus y plus 1 is equal to 0. If I was to solve it algebraically, what I would be doing is probably substitution again, because they tell you y equals something, so you're going to just plug that into the y. Now I'm going to rewrite that equation, 2x minus y plus 1 equals 0. Now I'm going to take that y value and plug it in there. The reason I use parentheses is because it's really important for you to make sure that that negative has to be distributed to everything. So 2x minus 2x minus 1 plus 1, as I rewrote that, equals 0. 0 cancels out. 0. 0 equals 0. Yeah, it's the same thing. It's infinite solutions. Now, what I want to make sure that you understand is the proper classification of these solutions. The first one, there is no solution. So if I asked you to classify that solution or that system, you would say inconsistent, because there's no solution, so it's inconsistent. Similarly, if I asked you to classify this one, where it's infinite solutions, I said, hey, classify the system. Then, because it's infinite solutions, you have an answer, so it's consistent. And because, again, remember, when I say you have an answer, it means that the lines cross. This specific system just happens to cross at both places. So it's consistent, and because it's infinite, it's dependent. So for some examples here, they want you to classify the system. So you're going to say whether it is consistent or inconsistent, and dependent or independent. And they give you the two equations, and you can, first of all, what you need to do is identify the slope of the first one. So if you take the first equation, 2y is equal to x plus 2, and you put it in y equals mx plus b, you divide by 2, you get y equals 1/2 x plus 1, of which the slope is 1. The y-intercept, therefore, is the b, is also 1. When you look at the second equation, negative 1/2 x plus y is equal to 1. You are going to add 1/2 x to both sides, and you put it in y equals 1/2 x plus 1. You notice that the slope of that line is also 1/2. Notice I made a mistake right here, so that is, the slope of the first line is 1/2, as you can see. And the y-intercept is also 1. So in reality, what you're doing is it's the same slope and it's the same y-intercept, which means it's the same line, which means you're going to intersect at infinite number of solutions. And when you intersect, it means you're consistent. And if you intersect at infinite solutions, you are dependent. To graph both of them, you would begin at 1 on the y-axis, up 1 over 2. Connect the dots. I go ahead and do the same thing with the blue, and you notice that it's the same exact points, it's the same exact line. So this one is consistent and dependent. For the next system, you look at the top one and you notice you have to distribute. So you distribute the 2, and you get y equals 2x minus 2, of which the slope is 2 and the y-intercept is negative 2. For the second equation, the slope is 1 and the y-intercept is 1. You have different slopes completely, and you have different y-intercepts. So that means that you are eventually going to cross, but only at one point. And to graph it so you could see visually what it means, y equals 2x minus 2, you begin at negative 2 and you go up 2 over 1. Y equals x plus 1, you begin at 1 and you go up 1 over 1. If I extend the blue line up 2 over 1 a little bit more, you notice that the blue line, which one? This one right here, and the purple line intersect right here at 3, 4. There's only one solution, so the solution is 3, 4. That's the point of intersection, and because you intersect, you are consistent, and because you only have one point, you are independent. And that's the solution to this one. Next example, before you begin your independent practice, is a word problem. So the first thing that we do is you have to make sure that you read it to create equations. Now, this unit is about systems. And because it's about systems, you know that you have to create 2 equations. Your job is going to be to create 2 equations. So let's read this first. Matt has $100 in a checking account and deposits 20 per month. Remember what the 20 per means. It means 20 multiplied by the number of months. Ben has 80 in a checking account and deposits 30 per month. Again, when you see the word per month, that's like 30 multiplied by the number of months. Will the accounts ever have the same balance? We want to know, will they intersect? Will they cross? Is there ever a value of x that is the same for both Matt and Ben? So let's make an equation for Matt. Let's make Matt purple. Matt has $100 in his checking account, plus he's depositing 20 per month. You can use the letter Y to symbolize Matt, 100 plus 20x, so that you have it in y equals mx plus b. Ben has $80 in his account, and he's depositing 30 per month. Well, the amount he has, which is the y, is going to be the 80 plus 30x. Notice I put these 2 equations in terms of y and x so that I could see them more like slope-intercept. With that, I want to know if they ever will be equal. So in reality, what you're doing is you want to know, will this amount ever equal Ben's amount? You solve for x. Let's minus 20x. So you notice that you have substituted for this equation. And you get 80 plus 10x is equal to 100. Subtract 80 on both sides. And you get 20 is equal to 10x. Divide by 10. And you get that x, which is the number of months, remember we said x was the number of months, is 2. What this is saying is that after 2 months, they're going to have the same amount. Let's see what that amount would be. So you would substitute that 2 into the equation above. And so if we were to look at y equals 100 plus 20x, put the 2 in there, you get 100 plus 40, which is equal to 140. So in 2 months, they will both have $140. If you had chosen the other equation, instead of 100 plus 20x, if you chose 80 plus 30x, you would have gotten the same thing. 30 times 2 is 60, and 60 plus 80 is also 140. So this is a way of finding a missing amount. What you guys are going to be doing now is you are going to be completing the independent practice. Choose the method of solving. So you could either solve by slope as well as y-intercept, or you could graph both of them, or you could use the algebra where you substitute one into the other or eliminate. So you will be completing all of these. You will get to choose your method. I am not going to worry about you having to do all of them my way. You get to choose which method you actually solve for. And then for the last ones, numbers 7 through 9 that you see here, what you're going to be doing is you're going to be classifying the solutions, classifying the system. So this is where you are going to either classify them as consistent, which means that there is an answer, and independent because there's infinite solutions, or consistent because you get an answer and you only get one answer, so that's and dependent. Or if they're parallel and they never cross, it is called inconsistent. So consistent means you get an answer. Basically, it's not no solution. Independent means that they are only one point they cross at. And dependent means that there's infinite solutions.